Okay, so doing a little bit of last minute review for kids that want to take the test on Friday. So this is review for the logs test. There's a lot of things. I'm not going to pretend that this is a comprehensive review of everything, or it would take us all hour. I did do a bunch of review yesterday too. Okay, so and the day before that. So if you want to watch the last 3 videos, you'll have a full review of everything. But for today, I wanted to start with one of these. Why do we want to make these have the same base so that then the answer is just the power? If these two are the same, then the answer's right there. Okay, so then how can I make this into 3 to the something? Hint, right away you need to get a 3 in it if you want the base to be 3. So do you get that that 1/3 is just begging to be made into a 3 to the -1? That was the key moment. If you didn't see that, you probably couldn't have got it. All right, so if that's a 3 to the -1, then what's the whole thing? 3 to the -1/8. And if you double check that and make sure that it's actually what we started with, this black problem here, then you'll know if you did it right. So is this really this? Well, what would the negative do? It would make it into 1/3 to the power of 1, which is 1/3. And then the 8th root of that. So, hey, that is that. So then the answer is -1/8. Did you happen to have that one? All right. Who had that one right? Raise your hand if you did. Ooh, a lot of people did. Okay, good. So that's an example. These are tough. I'm going to give you one more that's even tougher, but your brain's warmed up, so it may not be as bad. Log base 3/4 of 16/9 to the 4th root. 4th root of 16/9. Pause for a second. Let me give that one a try. All right, first thought. When I see one like this, I say, oh, I'm going to make this 9 into 3 squared. That's the only real logical thing I could make a 9 into. And do I want a 3 in my answer? I do. And then there's another one. The 16 could be made into, actually there's 2 options there. 2 to the 4th, but then it doesn't match the bottom as well as if I say 4 squared. Because then, oh, I got a 4, and it's the same power as that one was. So that's going to work out really nice. And then hopefully you're smart enough to go, it's upside down though. The 4's on top and the 3's on the bottom. So I better do something that will cause that to flip in there. So final answer, log base 3/4 of, again, we want this to be 3/4. I know this is 3/4. I just got to figure out what power. And it has to be a negative power to make that flip. It has to have a squared involved because of the 2's here. And it has to have a 4 involved because of that. And could you reduce 2/4 to 1/2? Yes. Raise your hand if you had that one right. Okay, good. Enough about the fraction exponents. Fractions to fraction exponents is nasty stuff. And we've practiced it a lot. I think you'll be fine on that. Next thing. Do you get how to combine logs, but with a twist? That adds the challenge. When you're in an honors class, you should say, bring on the challenge, Mr. Server. I can handle it. Let me think. Let's make this a 6. Sure. Okay. First thought. That little twist there, that little 3. Well, to put these guys together, they both need to be log base 2. I got to get rid of the 3 somehow. There's only one place you could put it. Do you know where? Up top. Right there. Some of you are like, what are you doing? You can move a power up to be the exponent. Let me prove it to you. You guys know what log base 2 of 2 is, right? What's that equal to? Log base 2 of 2 is equal to 1. Do you agree that there's an exponent of 1 on it? Do you agree that I could put that 1 down in front and it would still be the same thing? Now that's kind of cheating because it's a 1. All right, how about this? What's log base 2 of 4? What's that equal to? That's equal to 2. Do you get that this 4 could be thought of as 2 squared? Do you get, I'm going to move this 2 now down in front. and I still have a value of 4. Or 2, sorry. Well, sorry, 2. Again, this was log base 2 of 4, and the answer is 2. Even if you write it this way, log base 2 of 2 squared, the answer is still 2 because it's the exponent, because the bases are the same. Or it's still 2 if it's like this. I'm trying to prove to you that you can take a power on the argument and put it in front or vice versa. All right. So now that I moved that 3 up there, then this becomes log base 2 of x minus 4 to the third times x plus 4, and then it's only 1 log. That was the goal. I got my 2 logs condensed down into just 1 log, and that little pesky 3 has now become a power on that. Now, this one would be too hard for you on this test. This would be pre-calc could do this kind of thing, but you aren't ready yet. You at least would know that, I hope, that that is equal to that, but then you'd have to somehow solve this, and that's tough. So if I had a calculator, which you will on this test, I could expect you to solve that, but I know only a few of you would know how. Who remembers how? It's not that complicated. Yes? Nope. This is a way I've told you probably 5 times, but everybody forgets about it when the pressure's on. I'm like, how am I supposed to solve that? Graph both sides and see where they cross. I've given you this example like 6 different times. It's 6 different, but it's never the key way that you usually do it. Usually there's some other way, but this time, that's the only way. You graph the left side, y equals that. You don't even have to know what it looks like. Your calculator will do it for you. And then you graph the right side, y equals 6. Well, you know what y equals 6 looks like, I hope. Y equals 6 just goes through like that. And then this other one's this weird wave thing. And then wherever they cross, that's your answer. Now, again, that's nothing that hard on your test. I'm just trying to tell you a strategy that would work on any hard equation. You can say, bring it on, give me any equation. I don't care. Any equation, your mom or dad or whoever it is, your big brother that's in college math, and say, hey, give me any equation, I can solve it. They'll be like, you can't solve this one. As long as they can write down something that you can graph, just graph y equals the left side, y equals right side. They're going to cross. Wherever they cross, that's your answer. So it's a great method, and I'm telling you because it'll solve anything. Even if it's something like this, sine of 2x minus 4 is equal to 3 cosine of x. I got to keep the same variable. I have no idea how to solve that, except I could graph y equals this, and I could graph y equals that, and if they touch, then that's the answer. What if they don't touch? Then there's no solution. Okay, it's a pretty cool method. You should know that. But would you have anything that hard on your test? No, but you would have something this hard on your test. Try this one. Log base 7 plus log base 7 is equal to log base 7. Pause, we give that one a try. See? You should have said log base 7 of x minus 4 times x plus 1 equals log base 7 of 1. And then you leave the logs in the dust. Because there's only one on each side and they're the same base, that's got to equal that. So then x minus 4, x plus 1 equals 1. Then multiply it all out. X squared minus 3x minus 4 equals 1. Subtract 1 from both sides. Hey, I got it set equal to 0. If you can factor it, you should. But the only way to multiply to get a 5 is a 1 times a 5. And I'm not going to be able to get this to factor because x and a 1 and a 5, I can't make a 3 with a 1 and a 5. The outside and the inside never come out to 3. So therefore, if you can factor it, you should. But if you can't factor it, quadratic formula. Anyway, x equals negative b, which is 3, plus or minus square root of b squared, which is 9, minus 4ac all over 2a, and nobody messes up this number or that number. So if you did mess up, it'll be because of that. It's the square root of 29. And some people are like, but you didn't subtract them. There's 2 negatives, so you had to add them. 9 plus the 20 made the square root of 29. And that's it. What are those? Those are the answers. The answers for what? They're at x equals. So that's what x has to be. And I know they're weird numbers. Okay. Is it possible that one of them might cause it to be a negative argument or a negative base? Yeah. What if it turns out that when you actually figure it all out, one of them is negative 3? That's going to crash your function because when you put it back in, it won't work. So what we call that is an extraneous answer. So watch out for the extraneous. Now, I would not need you to actually go through and figure out all of this and find out what the decimal is, and then, okay, I would have you leave the answer like that, and that'd be good enough. But I hope you know that you have to check your answers to make sure they work. But this kind is too tough to check. So, all right, that covers some of what you need to know. Certainly not all. Now I want to open it up to questions. So are there any other topics, any type of question you saw on the homework last night or anything that you want to ask me? Yes? Mm-hmm. Now, at this point, I'm going to go on a little further with the fraction to fraction powers, but some of you are like, yeah, Jan, I've done this, I saw it 6 times, I got them all right, I'm good. Well, go ahead and start your homework. I would recommend the evens of the review sheet. For those that want to practice a little bit more on those fraction and exponent kinds, there you go. If I could make that into a 2/3 to a power, I'd have it. Try it, and when you start, I would look at the 27 and the 8 and see if you can write them with some different base. I'll pause for a second while you try that. Okay, so we start by replacing the 27 with a 3 to the 3rd. How about the 8? What could you replace that with? A 2 to the 3rd. That way, I see my 3 halves developing, but it's flipped from what I want it to be. So what do you think the final answer should be if I take my log base 2/3 and I write it with a 2/3 here to the power of what? What do you think? 3/5 negative. Now I'm going to see if you're right. I don't know. I'm going to check. First thing, it has a root on the bottom, which is good. The 5 is the 5th root. That's what we wanted. If I put 2 to the 3rd and this 3 here to the 3rd, that would be 2 to the 3rd is 8 27ths, and then the negative would make it flip from 8 27 to 27 eighths. You've got it. That's it. So then what does that mean? This equals this. All right, last thing I would review for those of you that want some more review is the most important strategy if you're stuck and you're like, how am I supposed to solve that? Always try for the rewrite, because the rewrite is the most important strategy for logs. So that makes this 5x to the 11th equals 4. But I was a little sloppy right there because I would probably get it wrong right now because I do it in the wrong order. What was I sloppy about? There's something missing. The way I wrote it, only the 11 is only going to go on the x. This whole thing is to the 11th. Now, why does it matter? Because if it's like this, your first step is to put it to the 1/11th power. If it was really like this, your first step should have been divide by 5. You would get 2 different answers. Get what I'm saying? On this one, you could divide by 5. But that's not how it really is. How it really is that whole thing has to be put to the 11th. Not just the right side of it gets put to the 11th. That's dumb. The whole thing gets put to the 11th. So it's parentheses like this. So you then would put it to the 1/11th. Ooh, did I just make it the absolute value kind? Because I didn't use an even root. My root part on the bottom. And now you're thinking back to your test going, oh crap. Was there one where I did the even root thing on there? Anyway. Okay, so you did an odd root, so you don't have to worry about it. And then you go, not absolute value, just 5x equals whatever in the world 4 to the 1/11th power is. It's icky, some decimal. And then you're going to divide it by 5, because then X will be alone. The rewrite is what I was trying to remind you there. You come full circle. There you go. Any questions? Any other topics you'd like to cover? Somebody had asked for some more fraction exponent stuff. And again, you guys can be working on your reviewer sheet right now. You just be fine. I would do the evens if I were you. Actually, if I really cared, because I'm not good at this, I would do the whole thing. If you've been one of my A students that's felt like you've been doing well lately, just do the evens. That'd be fine. Yes. Yes, sure. Let's say I had ln of 5. What does that really mean? Well, if you had a calculator, you could just type in ln 5 and hit the equal button, and it would tell you a decimal. But what you'd have to do is things like this. 5, actually, that wouldn't actually cancel nicely. How about this one? E to the ln 5. And I hope right now you're like, I have no idea what that means. But I'm going to replace the ln with what? Log base e. So if I do that, all of a sudden the problem becomes much more easy because you'll see the bases are the same. And then what's the answer got to be? The bases are the same, the answer's already there, and it's that right there. It's just 5. If you haven't caught on to that pattern, bases can be the same like this. And of course, if the base is the same like that, the answer is just 7. But the bases can also be the same like this. And if the bases are the same like that, the answer is also right there. It's just there already. No big deal. Answer's 15. Done. Okay. That was a little bit about ln. You want more about ln, or is that good enough? All right. If you want anything else, I can do more on ln, or I can do any other topic. So how would you rewrite something if you don't have a base? Like, how are you supposed to rewrite that? Yes? Yeah, like I said before, ln's supposed to be log base e, and then it'll have a base. What is the base? P. All right? And actually, we better make this like an L or something. Why? Because then I can actually write an equation. E to the 5th is equal to L. And E isn't a variable. E's a number. You got one on your calculator. It's right above the divide key. 2.718 approximately. Okay, I feel like you're pretty well ready. I'm going to stop the reviewing process here. And if you have more questions, you can come up and ask me one-on-one. That's all I got for the video for today.